piece of plasticine and
They already give mass, they already give height, they already give the time. So they want the force.
Yep, you are told a plasticine of plasticine ball bearing of the same mass drop vertically downwards. Calculate the average force for the plasticine and the ball bearing if the mass is 10.0 gram and the height is 2.0 meter and the duration of impact is 0.02 second. Yep. Any comment or any thoughts?
Where are
Basically, in force, you have to go back to.
Can use the V square equals to U square plus 2AS formula.
No, why don't you use that for what? Trying to do that for what? You must have clear understanding what you want to find. Force. What's the formula for force? MA. But A is not given. So
yeah, then we do the this one lah. The V square minus U square equals to S.
no need to go to
2S,
so basic.
sorry.
You can use the Newton's second law, M into V minus U over T. You are given the duration. So must be clear cut what you want to find.
Okay. 10 gram change to kg, so 0.01. And then A, what's that? V minus U over T lah.
Yeah.
So U is 0, V we don't know, so V over 0.02.
Huh? How to calculate your U and V?
We don't know the V and U actually.
Remember, we're looking at impact. We're not looking at when it dropped. So U we would know. We can calculate U. V is 0 finally. Because when it impact that's what happened. It will stop finally. But U is where it starts to hit the surface. Yeah. So basically,
Zero U is?
you can have to find U first by using conservation of energy. Right? Initially, potential energy. Finally, is kinetic energy. Then calculate your find the velocity at impact, conservation of energy, where V is the velocity before impact. Yeah, mgh initially, and then V is there's a kinetic energy, or the potential change to kinetic energy. Cancel the M. Then we can calculate our V. Okay. Now, so now that V becomes a U, the initial speed before impact, and then the final speed after impact is 0. Right? So now this one becomes your U. Final one is 0. Mass change to kilogram, and that is your time. Yeah, if you don't know, also write the formula down so that examiner can give you some mark for that. Can.
Okay. This is the hardest subject,
Harder because you're not doing any work. That's why you find it hard. I've been stressing with you to do work. Give you work, you never do. That's a problem. That's why
not only me, like everybody also, everybody study also same hard,
You cannot study one. It's like math. That's why I've been stressing at you. It's like math. You have to do the work. You cannot study one. Then you know how to apply the principle. Physics is a lot applying principle. That's why in Sunway College we give them the workbook that to do, the past year paper, 10-year series. Okay, let's go to part C. Bullet or mass 125 gram is fired horizontally. Right? You don't have to worry about friction. So we use conservation of momentum. Right? Initially, bullet, that's the speed of bullet, that's the mass of bullet. And there's the
Teacher, the B2, right?
ah,
Why never put the negative sign?
what negative sign are you talking about? No need to worry about negative sign, because you want magnitude only. They didn't ask you for the direction of the force. Calculate the average
Oh,
force.
yeah.
If you want negative sign, then you just explain, no?
Okay.
Right? If it's in on the plus sign, it's upwards. It's on the ground, it's downwards. So. Then the next part is conservation of momentum. Right? Okay. So that is your change to kilogram. Actually, it doesn't matter in this case. If you put gram, you can use gram if you want to, not necessarily to change the kilogram. Right? That's your initial momentum. That's the mass times the velocity. Initial momentum of the bullet. Block is 0. It's not moving. At rest, you're told. Right? Resting. Then after that, they move together. So you add the total mass. These two mass add together is 1.5. This is 0.125. That's the bullet. That's the block. And then they move together. Common velocity is v. And then just calculate out. Can?
Yeah, can.
If you got a friend you want to join for tuition, you can invite them. No problem. 2 person is $50.
I'll say like wait, what?
$50 each. 1 hour. Definitely they will need one. If they are not,
They all say like no money or something. They're telling like
no
that.
money. No money, then what happen if they fail? Fail,
I
you
don't
still have
think
to
they
repeat.
bother lah. They'll retake lah. Yeah.
Retake also the same. Unless you got somebody to help you.
But I know like one person only going tuition, the others all like not going. But the trial they're still failing, so no use.
Most of those who are rich one will go to Sunway College or Taylor's College already. That's why the poor one will go back to government school. But the teacher is teaching too fast. Anyway, let's go to what's the next question that you want to ask?
Number 2A.
Take Newton's second and
No.
yeah.
I mean number 2, the whole thing lah. Newton's
Okay.
second law is the rate of change of momentum of the body is directly proportional to the external force acting on the body and take place along the direction of the force. Third law is for every force there is an equal but opposite reaction.
Equal and opposite reaction. Okay. That one memory work. Resultant force acting
Oh,
on
it's
the body.
3 mark like that.
Yeah. Resultant force acting on the body is equal.
So I cannot waste this mark lah.
2 mark only lah. 1 mark only. 1 mark each.
No, it's still important mark what, out of 60.
Yeah, important. Memory work is important. Because there's memory only, not the difficult part. Memorize only.
Like I'll just score like maximum the one I know how to do.
That one you must score. That one must score if you want to pass. Newton's third law states that the action and react for every action there's an equal and opposite reaction. And after that, you apply the law. That's all. 4.5 kilogram rocket is fixed for vertical launching. The burn fuel is ejected with a speed of 800 meters per second. Calculate the mass of fuel ejected per second. So you want to calculate m divided by time, so that the rocket starts to move with an acceleration. This acceleration given, right? So that is your thrust. That's your thrust pushing the rocket up. There's the weight of the rocket pushing it down. And then there's the mass of the rocket times acceleration. So your T, right? How to find your T? T is the change in momentum. Right? Remember, T is the thrust. So you can calculate for change in momentum. Momentum is NV. So you have to assume your V is the one that's constant. The mass is changing, so it's dm dt. So now you replace that T there with dm dt V, and then take this mg minus mg to the other side. So you got ma plus mg here. Then after that, you want to find dm dt. Okay, dm dt, m into a plus g divided by v. Take the v down and put in your value. M 4,500. A is 10.5. G is 9.81. V total is there. 150 put inside there. Calculate. 91.6 kilogram.
Oh, that's all lah.
That's all.
Oh, so easily 4 marks aja, but need to know how to do it lah.
Yeah, calculation.
The derivation. Yeah, then B1 coefficient of static friction is what is that? The limiting frictional force is directly proportional to the normal reaction for case of static friction.
Yeah. It's the ratio of static friction to normal reaction. Okay, that's a mark you must remember. 3 mark there, you must memorize correctly. Ratio
No, this one I got it from this one lah, formula page. This one like the STPM physics Sem 1 definition list. They put there the limiting frictional force is directly proportional to the normal reaction for case of static friction.
That one is not a definition for the coefficient. The coefficient is just a ratio. F divided by normal reaction. That is what static friction ratio. That's what the coefficient is all about. Okay or not? The coefficient, how to find the coefficient? It's just the frictional force divided by the normal reaction. Okay?
Okay.
Right? After define, they ask you to do the question. Block A, that's a block A. On the horizontal surface of a table is connected to block B, that's your block B, by elastic string passing over a light and frictionless pulley. So you don't have to worry about the friction on the pulley, don't have to worry about the weight of the string. Block C is put on top of block A as shown in the diagram below. The mass of A and B are 4, right? Are given. This is 4, this is 2.2 kilogram. Coefficient of static friction between A and the table, right? That's a frictional force there. That's a coefficient. Determine the minimum mass of block C to prevent the block A from sliding. Okay, let's try to do work on that. For equilibrium, block A, right? You want to find the friction. So your friction is just your mu times your total mass, G, right? Normal reaction. In this case, normal reaction is this total mass, this M mass of block C plus mass of block A. Mass of block A is 4, right, times G, can. And put in your value, what is given, no? Coefficient is given. Mass of block A is given. Mass of block B, we don't know. We put it as M. Then your, right, that's your tension. Must be equal to friction if it's on the verge of moving. And put in your value. That's the equation 1. Right? Then we look at equilibrium of block B, this one. If it's not moving, then T must be balanced by your this mg, right? T M is 2.2, G is 9.81. That's the equation 2. So now that value of T, you can put inside here to find your M. Okay, 2.2 G, place inside here. There's your value there. Cancel your G, and then take your 0.25 across there. So you get 4.8 kilogram. Okay or not? Yep, can? No? Any comment? Anything not clear?
Not okay.
Okay. Next part, if block C is lifted, draw a diagram of the forces acting on the block. Let me just remove the thing first. Block C is lifted, draw a diagram of the forces acting on the block A and calculate the acceleration of block C is lifted. Draw a diagram of the forces acting on the block A and calculate the acceleration of block. Coefficient of kinetic friction between A and table is 0.2. Okay, let's do that. Okay, same forces there, except there's no block C now. Right? It's going to accelerate. Right? Just take out block C if you like. Or maybe I should remove it. Okay, maybe I should remove that. Okay, that is the question there. Right? Popular question. Calculate the acceleration of the block. So look at block A or block B first, whichever you prefer. Tension is still the same. These are the forces acting. There's acceleration is the same. So block A, T must be greater than F using Newton's second law. Right? The friction, how to calculate friction, remember, is just your normal reaction times your coefficient. Normal reaction is balanced by that weight there. Right? That's your weight of the block. That's how we get that. Then we can put in your value. Right? 0.2 here for mu. 4, 9.81, calculate out. Then we can look at block A. Right? Using Newton's second law. That's why they ask you to define, because they want you to use the formula. And T is greater than your F for it to accelerate. And put in your value. That's your equation 3. Then look at block B. Block B, F equals to MA. Right? There's your weight. Pulling it down, 2.2 G.
Can you go back to B2 again?
B2. This is your B. Oh, B2. Yeah. That's the problem.
Again, mass equals to 4.8 kilo, not gram.
We convert it to kilogram.
Okay, okay.
The answer is in kilogram.
All right.
Okay.
Okay.
Cannot mix a unit, or either gram or either kilogram. So use all SI unit lah, then you won't get confused.
Okay.
Okay, any comment on this part?
So how come your picture there got no block C? My one got block C.
Hey, part 3, part 3, you remove block C, that's why I remove block C. Okay,
Okay.
so you won't get
Okay.
confused. Yep, okay, next question.
Just a minute. Okay.
Okay, in case you are still lost about all that, there's a formula that we use for vertical equilibrium. Okay, next question. Yep, we have completed our dynamic. Shall we go to work done? Any question you want to ask?
No, sir.
Then what do you want to do?
Can we do chapter 5?
Chapter 5, okay. Let's go to chapter 5. Chapter 5. This last part, you need to do the question. No choice already. You don't do, you cannot answer the question. Make an effort. Chapter 5, circular motion. Okay, let's go roughly what you need to remember. Right? Basic formula, distance is over time. So you go one round, one revolution, there's your circumference divided by period. Okay, that's how you memorize your velocity and relation to period. And if that's the mass of the body, m, and centripetal acceleration is v squared over r or r omega squared. Right? That's your omega. V acting on the body. V is called the linear speed or tangential speed. Usually it's uniform. And then there's the direction of the centripetal force or centripetal acceleration perpendicular to V towards the center. And that's the angle. We call it displacement, not angle. Angular displacement because it's a vector. Yes, either clockwise or anti-clockwise. Right? And omega. Omega is your angular velocity. It's a vector, either clockwise or anti-clockwise. Right? If it's constant, then it's theta over t. If it's changing, then it's d theta dt. And how to calculate? If it's one round is 2 pi radian. Then your t becomes your period. Then v equals to r omega. Memorize that. Remember, the centripetal force is the resultant force acting on the body. We can calculate the value. Right? It's called centripetal force. It's a resultant force. And how to the condition? The force is always constant in magnitude, but perpendicular to velocity. Or we can say it's always directed to the center. That's the condition for centripetal force. For it to work with circular motion. I can see that it's a common question. Objective will come out one question. Okay, a particle of mass or ray in okay, question 1. A particle of mass 0.2 kilogram is attached to elastic string, elastic string key, which is fixed at one end on a smooth horizontal table, smooth, no more friction. Length of the string is 0.5 meter with a force constant. So basically like a spring. And the particle is moving in a horizontal circle of radius 0.65. Right? That means this is the original length 0.5. This is the extended length 0.65. What's the angular velocity? So you have to remember your spring formula and the centripetal force formula. So they want to calculate angular velocity. Okay, so essentially if they give you a spring constant, then you must be able to calculate the force on the string when it's stringing. Right? So your elastic force is F equals to Kx. Right? K is 40. Your final length, right? Final radius, initial radius, subtract, that's your extension. Calculate out 6. So that is your centripetal force. Right? So it's an elastic force, provide the centripetal force, mr omega squared. In your value, right? And to find omega, take the mr down, then square root it. That's what you get. So put in your force, 6. Mass, that's your mass. Right? That's your radius. That's your radius. Calculate out. Can? We have to stop in 10 minutes time.
Yeah, can.
Yep. Annie, are you all right? If all right, we go to question 2. You must do at home. Cannot come copy. You won't learn anything.
Yeah, okay, teacher.
Question 2 is it?
Yeah, question 2.
Right? Must
The
remember
answer is C.
all these. If you can memorize it, good. Right? There's a wooden block, inclined plane to horizontal theta. So must remember there's your theta, there's a W cos theta, there's a W sin theta. Always replace your weight with the two component. Same, right? If there is your normal reaction, you want to resolve it horizontally and vertically, the angle is theta. So the angle is also theta, right? Angle, theta, this theta. You can remember easier. Then resolve it horizontally, right? So rectangle, vertically and horizontal component. Yeah. So this is your n sine theta, this is your n cos theta. So same as here. A car of mass m is moving along a sideway slope with a center O. Right? That's your center O. That's your radius, as shown below. If n is the normal reaction on the car, that's a normal reaction, and F is the friction on the tire, that's your friction F. Centripetal force on the car is, so in this case, remember, it's moving in a horizontal circle, that's the center. That's a horizontal radius. Yeah, very kindly draw for you. So it means you can resolve all the
Point your mouse to the theta, teacher.
yeah.
The one the down theta there.
That's your theta. That's
No,
your
no, 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 no. The other, yeah, how you get that theta? So that one only I confused a bit.
that one you must remember. That's your theta. That's your theta.
Oh,
Yeah.
just remember only lah.
No, the mass is there. We have done so many times already. Basically, let me just go over with you. There's your rod. You've done that already. Just say, oh, cannot remember. If if you can remember like that, easier. If you cannot, go back to work it out. Right? There's your angle theta. So basically, we are just right? We are just slide this one down. That's all. We didn't do anything illegal. And then draw your vertical line. There's a vertical line. Yeah. This is theta. This is 90. Right? This is 90 minus theta. So these two must be equal. Can or not? Yeah. That one is 90. That one is 90. Yep. Can or not? It's easier to remember. Memorize it. Cannot.
Wait,
90. 90. Right? This triangle is also 90. Right angle triangle, this one. So this is 90 minus theta, this angle. Angle, 90 minus theta. So this must be equal to theta, this one, this angle. Yep. What's the problem? Yep. Why so long? What is the problem? Why I cannot understand?
No, I can.
Okay, I think we might as well take 10 minutes break. You can use the time to do whatever question you haven't done, or you want to take a drink, whichever you prefer. Okay.
Okay, Chair.